Thank you so much, everyone, for joining us today, and welcome to our webinar, GeoCognition, Next Gen Mapping with Gaming Tech. This webinar and the accompanying Global Digitization Challenge are part of the YouthMappers celebration of GIS Day and Geography Awareness Week, highlighting innovative ways to engage with geospatial technology. So today we're going to explore how GeoCognition's Linear Features app uses gaming-inspired tools to enable participants worldwide to contribute to a global mapping project. And to guide us through this, we have Dr. Kumar Navulur, founder and CEO of GeoCognition. And so the floor is yours. Thank you for being here.
Thank you, Elodie. Good morning from Colorado. I'm in Colorado, United States. Quick background, I got my bachelor's in civil engineering, master's in remote sensing from IIT Bombay or Powai, it's called these days, and PhD in remote sensing and GIS from Purdue University, Indiana, United States. I've been in the satellite remote sensing industry, GIS mapping for 30 years. So hopefully today you will find it interesting on how we can use gaming technologies to make some of the maps easier. So with that, so the idea started with my son, who is now 18. He was playing a game called Fortnite. I'm sure some of you are aware of this game. And what was interesting for me was there were multiple players playing the game. It happens to be a fictitious island, if you may. And the way the gaming was able to handle the 3D data was amazing. By the way, my background, when I was at Purdue, I wrote the first web mapping service in 1995, dating myself, with a software called Grass GIS. Some of you might have heard of it. It's an open source software. And since then, I think we have come a long way in terms of the gaming technology as well as the web mapping services we provide. So when I think about gaming technology, there are several advantages. The first one, which I was about to explain, is the superior user experience as well as the interface. And as you all know, the games are designed so that the gamers can be there for hours without the human fatigue, which is amazing. I think that itself brings a new dimension to mapping, in my opinion. Second one is for those of you who have been doing OSM and other digitization, you typically end up having a mouse and you're clicking the mouse to digitize features. My background, I did a lot of digitization. I worked on land use, land cover, impervious surface mapping. So I'm very familiar with how people use GIS to do uh, digitization and create various maps. And I believe that the various controls, gaming consoles, and others allow you to use a lot more of your fingers. Sometimes there are driving games where you're using your feet and toes and voice recognition, you name it. I think the latest of the technologies we are able to incorporate from gaming, and I think we can leverage them in mapping as well. The one which I started mentioning is how it handles 2D, 3D, and 4D data. Even now, the reason I was mentioning about my web mapping service background was if the data is not cached properly, and when you're logging into these image servers, you can actually see the tiles popping up. Whereas when you talk about a gaming experience, it has to be seamless. The best example I think I can give is the game Grand Theft Auto. I was amazed when a car goes by, you can actually see the blades of grass move. You can see the little pebbles being rolling across. So the 3D, the way the gaming is handling, I think is much, much superior than the geospatial technologies and the GIS technologies we do today. The other one is the massive multiplayer online platforms. When Pokemon Go was at its peak, on any given minute, there were typically multiple hundreds of thousands of users globally playing that game. The ability to handle multiple people, the ability to basically keep the history of what they have done in the past. These are all, I think, important things we can actually leverage while doing mapping. And then the last one I think is uh, last two is basically when you talk about these devices, they are designed in such a way that you can actually, they're all are haptic technology based sometimes. You can actually, the gaming consoles have all kinds of controls you can use to play the games, which can translate to better mapping tools. And then lastly, which is my favorite statement, is you can both obey or disobey laws of physics. What I mean here is that somebody can jump from a 20-story building in a game and just walk away if you may, and you can have planes, cars racing at 800,000 kilometers an hour, which is practically impossible in this world. But you can actually basically disobey the laws of physics, if you may, in these games. So. Bringing all these things to from gaming technology to mapping, I think provides a lot of interesting opportunities. So without further ado, I will introduce how this particular linear app, which is an app that works on iOS, Android, and web. Hopefully you have one of these three, one or more of these three operating systems. You can actually play with this particular technology. So in this case, this is on an iPhone. You see the white dot. You're using your fingers on an iPhone on a smart device. I'm now trying to digitize I-70, which is an interstate in Wyoming in the United States. And you can see that I turn the image in the direction I want to run. That gives me the speed. And that avatar, every step that person is taking is being recorded. And I'll explain, I have a detailed examples on all these controls, but you can see that the button on the right-hand side, if I want to increase the speed, I just push up, and then that person is basically, this is at this point, this is the hand-eye coordination with the gaming interface you're able to map. So while I was discussing that, we mapped roughly to 2 kilometers. So when I do these things, on my iPhone, typically interstates, I map at 400 kilometers an hour. And then when you get into rough terrains, and I'll show you some examples, it's typically around 30 to 40 kilometers an hour. I had one of this linear app actually on Xbox, and I had a professional gamer map it at speeds of 800 to 1,000 kilometers an hour. So we're talking about some serious speeds in terms of mapping linear features. So where do you get this app? I will try to share this deck with you. If you just type in Kumar Navulur, my name in Apple Store, you will find this app. I call it Lines and Points. You will find it there. I am trying to upload the app onto Android. Right now, I have a different version, so please don't download that. But if you have an Android phone, just email me and then I will send you the APK file you can install on your phones. And then on the web, that particular link, the data.geocognition.com and web Google line points. By the way, the background right now, I'm using Google Maps. I have links to Mapbox as well as Cesium. Both Cesium and Mapbox allow you to put your own imagery and maps. So for custom projects, I typically end up using either Mapbox or Cesium. And I'm sure by now you're aware that all the three platforms have developed APIs for gaming. And in terms of the APIs, there are two big programming languages. The first one is Unity. The second one is Unreal Engine. And in this case, I'm actually using Unity because the developer I picked happened to know Unity. But if you're a fan of Unreal Engine, you can create similar apps as well. So here is the first screen when you log in. I believe this is the first time you have to do it, and then after that, it jumps straight to the next screen. At this point, I recommend that you just select play as guest because I have not started the whole username password. While the background I'm using is a big gaming console player management platform, at this point, I recommend just use play as a guest. And these apps right now I'm showing are all about Android and iOS phones. And I have one slide that talks about how do you do this on a web platform, on a PC or a desktop computer. So once you log in as a guest, this is the screen you will see. Uh, this is where I want to mention that enter a name. Please pick a name that's unique so that uh, those files you create will have an extension based on this particular name you enter here. Typically, I end up using the name of the interstate, but for this particular competition, either you can pick your initials or come up with a name that uniquely represents you. So when I provide you back the KMZ files, the file name will start with this particular name. So once you type in your username, if you may, and click start, this is the main interface where you see a 2D map of the world. And that if you see in the middle of the screen, there is a yellow, white dot. That is the one you basically move around. By the way, this is all based on haptic or fingers touch technology. You can use your fingers to pinch in or pinch out. And then you find any road, any rail, I have even digitized coastlines. You can go anywhere across the globe. This is Google Maps, and then find a road you want to basically digitize. And I would recommend zoom in as much as you can so that you can precisely position that white dot on where you want to start mapping. And then you can press start. The other option you also have is if you know the latitude, longitude, typically what I end up doing is I go to Google Earth and find a road that has not been digitized and then get the latitude, longitude, and then type those in the top left boxes and then hit spawn, and then you will automatically zoom to that particular location. So you have the two options where you can just use your zoom in, zoom out to find the area where you want to map, or if you already have a latitude or longitude, you can type in and press spawn. And if you press menu, you will go back to the login screen. So at this point, I'm going to ignore the settings button. There are a lot of functionalities built in, which we are not going to use for this particular competition. But when you download the app, feel free to play around with the settings as well. So once you select that particular location, in this case, I think this was someplace in Africa. That particular dirt road was not digitized. The key thing here is, as I was mentioning, is rotating the image in the direction you want to go. Um, so, so let me explain a couple of things. There are two options on the left-hand side. One is called camera. Camera, think about it as setting the zoom level of what you're seeing right now. You can, if you're digitizing an interstate, you can basically zoom out a little bit. That makes things faster, and vice versa. If you're digitizing a dirt road, or if you're digitizing roads in favelas, you might want to zoom in a little bit. But the extent what you're seeing on the screen stays the same. You're just moving in and out. So that is the camera option. The next one is the speed. Uh, at 400, you're going really fast. Once you get used to this, I typically am at 400 when I'm digitizing these features, but I would recommend to start slowly. So wherever the default is, you can leave it there. But as you get comfortable, where your hand-eye coordination, you're able to stay on that linear feature of interest, you can absolutely start increasing the speed here. So the radial button on the left, you can basically turn the image. So the best way you get your speed is turn the image in basically facing up. Using this particular button, you can basically pull it in any direction you want. So it will turn the image. By the way, the speed I talked about also impacts how fast the image turns. So this is one of the key things. Always you will have at least your thumb or some of the fingers making sure that the image is being rotated in the direction you want to go. So imagine that at least your left thumb is always on this particular button. And then same thing with the speed. You just pull up and down. So if you pull up all the way, you are starting to go faster. And when you hit something like a curve, you basically slow down. Again, once you start playing with these two buttons, these are the two key buttons. Basically, it's your hand-eye coordination. I think you should, if you're a gamer, you should be able to figure this out pretty quickly, how to turn the image and how to go faster or slower depending on the type of the feature. This is the big one. Once you're ready to digitize, you have to press record. And then when you press the record, that black box will turn to a green box or green letters saying it's recording. This is something initially I made a lot of times I forgot. I would be basically digitizing a lot of roads only to realize that I have not been recording them. So, but anytime you press record, let's say you're running a road that is 10 kilometers, you can keep going. And when you reach your end point, you can say, press record again to stop it. And then the box will turn back into red. That's when you know that you're not recording anymore. It's also, this is important if you're digitizing roads that are not contiguous. So let's say you decided to digitize a road in Congo, and then you just moved along and say, I'm going to do something in Tanzania. Then what you do is the same thing. You stop recording, go to the new location wherever you want to go, and then you press start again, and then you can start recording that particular road. Um, it's not a big deal if you forget to do that. What happens is, in terms of the back end, and I'll talk a little bit more about how the back end works. If you don't press stop, the last point you digitize in the new road in Tanzania, there will be one line connecting that two. So basically, stopping and starting is the best way to digitize roads that are not contiguous or next to each other. So one of the things, there is a radial button at the very bottom of the screen, and it says double click. If anybody is interested in digitizing, especially roads in urban areas, as you know, they're all small roads. They stop and go. So this is where you can actually press the button called double click, and then you can click on the new point where you want to start recording, and then it automatically moves based on this particular button. When you move to the new place and you're ready to go, you double click again, and then you will get back to the previous controls we talked about. This is really useful for urban areas where you have a lot of small roads crisscrossing each other. Very good option. Again, if you want to play around, you can do that. But for the competition, I think to make it fun, I think I'm going to basically look for how fast can you guys digitize the long roads. So maybe this is not of interest for the competition, but if you want to play around, this is meant for short urban roads, if you may. So this is what it looks like. As I mentioned, this is an example. The green or cyan line is where I was running, and I kept turning the image so that the image is always pointing up. And that little avatar you can see. And what happens is to save memory, especially on smart devices, I leave those arrows, location icons, and then as you run for a minute or two, the cyan color road will disappear and you only see these arrows. So it is just to make sure that you know that you have already digitized that particular road. The other key thing is the box on the right-hand side, especially when you're digitizing, stopping and starting again. Sometimes you don't know, were you going north, were you going east, were you going south? So this particular top box is oriented towards the north. So always keep an eye. When you stop, you might just write down saying that, yeah, I was going down south or on this particular road, or I was going east. That way, when you start back again, you can continue from that very point. and then remember which direction you're going. So this top box is very important so that if you're stopping and starting again, let's say today and then tomorrow, keep in mind which direction you were digitizing, and this is the box that will tell you that. So we talked about a lot of the controls so far are the controls on the iPhones, the smart devices. I have the same thing for the web, which is the address I showed you before. And these controls, I am not a gamer on desktop, but if you are, these controls should look very familiar. The only thing I can say here is that to move forward, you basically use the arrow keys as well as those different letters you have here. And then you use the mouse pad as well as the touchpad if you have a laptop to basically move the image in the direction you want to go. So here are the various controls. They are very similar to the controls on apps on smart devices, but a little bit different on the web for a desktop system here. So a lot of you might be wondering, how do you, once we get the data, how do we get to something like a GIS vector? So think about it this way. Whenever that you press record, every step the avatar is taking, the XY is being digitized, and then it goes to a cloud where it is being stored. And that username, and then we'll add the date and then few other things that make each one a very unique file. And to save the memory on the computer or on the phones, we basically every 1 minute to 2 minutes we create files and then send them back to the cloud. So that's part one, is think about it as an XY file with every single point you have digitized. And then once I have that, then you can use an Esri software or QGIS or any GIS software to convert these points into lines. And once you have the lines, one of the things I realized was I was mapping roads in the entire country of North Korea. And that file was 350 megabytes because it was too dense. So I had to use something like a Douglas Puker algorithm. I went up to 6 decimals in terms of the accuracy to basically simplify the lines. Otherwise, the files were too big. When I record these XY from the games, they are up to 8 or 10 decimals, which I think is an overkill given that we want to be within 1 meter precision, if you may. So I think five zeros, I think, is a very good way of taking these points, converting into lines, and then simplifying them. And then once you have that, I'm sure you're all familiar with this, you can convert the lines into any GIS format you like. Right now, my plan is to provide you KML or KMZ files, as well as if you're interested, I can also do Esri shape files. So here are some of the examples. This is where I live. This is Interstate 25 that starts in Wyoming of United States and goes all the way to end of New Mexico. Back and forth, it's around 3,500 kilometers. I went back and forth in 8 hours while also digitizing various points of interest along the linear features of interest. That includes bridges, overpasses, culverts. So these were the 25,000 points I basically digitized along with the linear features, in this case, interstate of 3,500 kilometers, all on my iPhone, sitting on my couch in 8 hours. To give you an idea, this is all about hand-eye coordination. And then I'll talk more about how we can leverage this for AI ML. But this is a road in Himalayas. So I was able to do around 30, 40 kilometers an hour. This gives you an idea because I was trained on this. I was able to map positionally accurate these linear features. Once you get used to this, the two radial buttons of turning the image and controlling your speed, you can actually master and be very, very accurate in digitizing these linear features. This is in Nigeria. I think within 8 days, I was able to digitize around 15,000 linear kilometers of the road. One of the interesting things I noticed in Nigeria were some of the roads would be underneath the trees. And the beauty is, as with our hand-eye coordination, you can actually guess that, oh, this is the missing portion of the road. So I was able to actually connect. I would slow down and then figure out what the particular road connection point is and actually digitize those roads which are underneath the trees because there are portions of the roads that are visible. So this is another advantage of the hand-eye coordination. The human cognition is really good at connecting those dots. So this shows an example that, and some of these roads were actually dirt roads. They were not paved roads either. So you can basically digitize anything. If you see it, you should be able to map it with this app. This is an example actually where I was born in India. I was able to map rails, roads, and then even waterways, as well as some of the points of interest like bridges. So I'm just giving you an idea. Basically, any linear feature you can see, you should be able to map it. So in terms of the competition, we will have 2 weeks. What I'll do is at the end, I will go back to that slide where you have the locations for where you can download the data. But the competition window opens after this one. Once you download it, you can start playing around it. And then my goal is after November 24th, starting 25th, I'll basically convert by that unique name how many kilometers you have digitized. And also I will look at the accuracy. So those will be the two attributes I would look at, how good you are and how fast you are. And then for anybody with an Android operating system, please send me an email. I also put that in the chat. And then my goal is to have all the results published by December 7th. Um, and I will working with YouthMappers, I'll make sure you get the results back. So now think about this whole as a framework rather than just an app. So I'm using the gaming technologies, some of the features we talked about. So far I have developed 5 additional apps. The first one, what I call vector features app, where instead of using a GIS for mapping points, lines, and polygons, you can actually do that using an app on your smartphone. QA/QC app. This is something when in my previous company, we were creating mosaics of the globe, and typical map errors or image mosaic errors are warped roads because the elevation model is bad. Sometimes the roads will be offset. There are several artifacts that come together. And given that our landmass is 150 million square kilometers, there is no way you can actually do quality control. That includes both maps as well as imagery as well. So I created an app which I call QA/QC app, where 4 of us looked at every single image tile in North Korea in 1 week. If I had 16 people, I can look at the entire country of North Korea, which is around 130,000 square kilometers every single day, and identify all the image or map tiles that have errors, if you may. And you can also use the QA/QC app to find where the roads are not digitized. So there are several advantages. And then that also applies to AI/ML. Once you run your AI/ML, and then if you want to validate the object extraction or feature detection results for large areas, this would be a great app as well. 3D, it's about what I call getting coordinates in XYZ. The best example I give is if you live on a 20th apartment or a flat in London, it's just a matter of time. You can expect your groceries, everything to be delivered to your balcony. And if you want the XYZ, now 3D models are being built for every city, whether it's for building information modeling or just for 3D modeling smart cities. So you can bring that real world 3D data onto your app, and then you can identify the XYZ locations of where you want things to be dropped off, if you may. And as I mentioned, you can use the app to create labels at scale. If you're trying to map airplanes, trucks, you name it, or even features, you can actually do that on your smart device. And then the last one is I'm passionate about how you can actually understand this condition of the infrastructure. Once you digitize the roads, then you can actually have an app where it basically scrolls slowly along the line, and somebody can inspect it visually. And if they find a pothole or some problem with the road, using voice recognition, they can say, here is a problem. And then that particular location will be recorded. So think about this, the whole technology where you can create new apps for various specific missions. So here is my contact number. You can find me on LinkedIn. As I mentioned, knavulur123@gmail.com. So I will go back to the website, to the page where you can download the apps in a second. And with that, I will take any questions here.
Oh, sorry, Kumar, could you hear from my side? I'm not sure that it is just clear or is it fine for the sound? Okay, yeah. I got a question because I can introduce myself first. That I'm from the Chair of Cartography at TU Munich. So we are also very glad to hear from your side. And I wonder, like, so you have mentioned that you developed it by the Unity and also the Android version. I wonder that is it also possible to deploy it in the glass space, like those like HoloLens or like the MetaQuest or Vision Pro? Like, have you tried that or developed by that way? Yeah. Thank you.
I have not tried the Linears app on the lenses, but I have a whole AR VR app for something else. Short answer is yes, you can do that. And there's a question about can this work with internet right now? Because the backend is Google Maps or Mapbox or Cesium, you need to have connectivity to the internet, preferably where you have Wi-Fi so that you can get a seamless experience.
Hello.
Yeah, go ahead.
Yeah, I was the one. I'm Yusuf Toure. I'm currently in Liberia, but I'm an Ivorian, and I was the one who was asking about the internet aspect. Yeah, in fact, that I'm living in Liberia and started digitalizing in Liberia, and after I'll go back to Cote d'Ivoire, where I'm planning to go, can be linked as
Yeah,
a competition as well. I mean, starting in Liberia to go to Cote d'Ivoire, or I must be on.
no problem. All I need is your unique ID. And if you're doing it across the globe, even better. If you're moving around and doing it. So yes, no restrictions whatsoever.
Nice, thank you.
Yeah, I'm actually glad to see global participants here, and I'm hoping you'll like this app because once you get the feel for it, it's pretty intuitive.
Have a great day, everyone.
Thanks, everyone.
Nice.
Thank you.